Welcome to Vibe Sense. All right, let's get right into it. We are talking about something incredible today. A visitor that has been traveling for billions of years, and it's about to fly right through our cosmic backyard. And listen, this isn't just, some random rock. We're talking about a relic from the literal dawn of the galaxy. It's a time capsule that was already ancient before Earth even existed. Get this, 7.5 billion years old. Let that sink in for a second. Our entire solar system, everything we know, that's only about 4.5 billion years old. So yeah, this thing has been around the block, to say the least.
And it is not here for a long visit. It's absolutely blazing through our neighborhood at a staggering 130,000 miles per hour. I mean, it's just passing through, a fleeting guest that we'll see once, and then it's gone forever.
Okay, so let's properly introduce our ancient interstellar visitor. Its official name is 3I/Atlas, and figuring out its story, well, it's kind of like a detective novel, with clues scattered across the stars.
So what is this thing exactly? 3I/Atlas is what we call an interstellar comet. And that name, 3I, is pretty cool. It literally means it's only the third interstellar object we have ever confirmed. Think of it as a giant, natural snowball of ancient ice, rock, and dust that got flung out of its home star system a long time ago. But how in the world do we know all this stuff? I mean, it's not like we can go grab a sample, right? It all comes down to piecing together clues, like cosmic detectives, from millions and millions of miles away. And of course, we have to ask the big question. You know the one. Anytime something shows up from another star, people wonder, could it be aliens? An alien probe? And that's not totally out of left field, because that idea got a ton of buzz with our first interstellar visitor, the super mysterious ʻOumuamua. So here's where things get interesting. The key difference between them really comes down to how they acted. ʻOumuamua was weird. It didn't have a visible tail, which left the door wide open for all kinds of speculation. But 3I Atlas? It's much more of an open book. The Hubble telescope got these beautiful, clear images of a coma, that glowing halo of gas and dust, and a tail. It's acting exactly like a comet is supposed to. And its chemistry, what it's made of, tells a really fascinating story. Yes, scientists found the usual suspects: rock, dust, and ice. But the real smoking gun is that it's unusually rich in carbon dioxide. Now that is a huge clue. It tells us it probably formed way out in the freezing cold outer edges of its home star system, a totally different kind of neighborhood than where our own comets were born. So when you put all these clues together, you can start to trace its just epic journey across the galaxy. This really isn't just a rock, it's more like a message in a bottle, sent from the ancient universe. I mean, just think about this timeline for a second. It formed billions of years before our sun was even a thing. Then it just drifted, alone, through the Milky Way for eons, until our telescopes finally spotted it in July of 2025. And this winter, it's going to make its closest pass by Earth, and then, poof, it heads back out into the void forever. So you might be wondering, how on earth are we getting such a good look at this tiny, super fast object? Well, it's all thanks to a truly incredible global effort. Yeah, this isn't just one lonely telescope squinting up at the sky. No way. It was first discovered by the Atlas Network, which has telescopes all over the world. Then the legendary Hubble gave us our clearest images. And get this, the ExoMars orbiter literally took pictures of it from another planet. And there are even spacecraft out near Jupiter getting ready to watch it. It's a real all-hands-on-deck moment for astronomy. Okay, so at the end of the day, why does any of this matter? Why should we care about some distant icy rock? Well, it's because its brief visit is actually a really profound moment. It's not just about the science, it's about changing our perspective on our place in this huge universe. The physicist Brian Cox really hit the nail on the head with this. He said, only 400 years ago, we were still debating whether the Earth orbits the sun. Now we are taking photographs of interstellar comets from the surface and orbits of other planets. I mean, think about that leap. Just a few centuries ago, we were still figuring out our own backyard. Now we're taking snapshots of visitors from other star systems using robots on other planets. That's just a remarkable story of human progress.
So what it all boils down to is this. This comet is basically a free sample delivered right to our doorstep from an alien star system. By studying what it's made of, we can start to chip away at some of the biggest questions out there. Like, are the building blocks of planets the same all across the galaxy? How many of these interstellar visitors are actually out there? We're literally analyzing the raw ingredients from a distant corner of the Milky Way. And finding 3I/8less proves that we're getting so much better at spotting these travelers. It really makes you wonder, doesn't it? What other secrets, what other ancient relics and messengers from faraway stars are drifting through that vast darkness right now, just waiting for us to find them? Thanks for watching VibeSense.